Okay, so we're going to talk about another way to solve systems besides graphing. So this is the second way. This way is called the substitution method. We typically use the substitution method when step one is already done for us. So let's not look at all of the steps at once. So step one is done for us, or if there's a variable that has a coefficient of 1 or -1. So step one says you're going to solve one of the equations, so you pick one of them in the system, for one of its variables, so either x or y. Doesn't matter which one. I know with graphing we were solving for y, so it was in slope-intercept form. Here we are just solving for either of them, as long as one of them has a coefficient of 1 or -1. That's typically the only time we want to use substitution. The other times we will use what's called elimination, and we'll talk about that later. So once you have solved one of the equations for a variable, then you would move on to step two. Step two is substituting the expression from step one. An expression, remember, is something that does not have an equal sign. It's a statement without an equal sign. That expression is, if I'm looking at example one, the part that y is equal to. Okay, so 3x plus 2 is an expression. So you would take the expression from step one and substitute it into the other equation. It can't go into the same equation with that expression. It's got to go into the other one and solve for the variable. Okay. After that, step three is we're going to substitute the value from step two. So after we substitute, we then solve. That means we're going to get x equals some number or y equals some number. We're going to take that number and we're going to substitute that value back into the equation from step one. And then we're going to solve that for the other variable. Okay, once you do that, you have both your x and your y number, and that is your solution. After you get your solution, the final step is to verify or check that solution by taking the ordered pair and plugging the numbers back into the original equations. Notice that's plural. It's got to work for both. The other way that you can check is by graphing using a calculator, only if you can get the equations, both of them, into slope-intercept form. Okay? All right, so let's take a look at the steps with an example. So the example is y equals 3x plus 2 and x plus 2y equals 11. Step one is we're solving one of the equations for one of its variables. Again, we're choosing one that has a coefficient of 1 or -1. So this equation is already solved for y, so I've already technically done step one. If it wasn't solved for y, we could also use this equation to solve because the x has a coefficient of 1 right here. We look at now step two. We're taking the expression from step one. So remember, the expression is the statement after the equal sign here. And we're substituting that expression from step one into the other equation. So I'm taking this expression and I've got to put it in this equation. Well, I can only put it in for y because the expression tells me that it's equal to y. So because it's the same thing as y, I can put it in for y into the second equation. So here's how I do that. I'm going to write the second equation. You write x plus 2, and then a set of parentheses equals 11. And then I'm going to take that expression and put it inside of the parentheses. After you've substituted that expression in for y, we just solved this multi-step equation for x. I know I'm allowed to substitute it in for y because, again, the first statement equation says y equals this thing. So I'm allowed to take out anywhere I see a y and plug in that statement. I have to put it in grouping symbols, though, because I need to multiply the 2 by everything that the y is. And the y is all of this, not just the 3x. So if I don't put these grouping symbols right here, you're only doing 2 times 3x, and you won't be able to do the 2 times the 2. So the grouping symbols are always necessary when you're substituting in. So like I said, now we're solving this multi-step equation for x. When I'm looking at this, the first thing I have to do is get rid of grouping symbols by distributing. So I get x plus 2 times 3, which is 6x, plus 2 times 2, which is 4, equals 11. After I do that, I check for combining like terms. I see x and 6x, so I combine those to get 7x. I can't combine 4 and 11 because they're on opposite sides of the equal sign. I then check for moving variables, and I don't need to move variables because I only have one. So now I get rid of my constant, and I get 7x equals 7. After that, I get rid of my coefficient by dividing by 7, and I get x equals 1. Right? Now that I've done that, that's all step 2. So step 2 was substituting in my expression. Step 1 was solving one of the equations. Now step 3 is taking that number, x equals 1, and plugging it back in. So taking the value, x equals 1, and plugging it back into the revised equation from step 1. So that means the equation from step 1 is what I'm going to use. So I take the equation from step 1, y equals 3 times whatever x is plus 2, and I take my number for x and I plug it in for the x value. From there, I just simplify. So 3 times 1 is 3 plus 2, and then 3 plus 2 is 5. So y equals 5. Once I've done that, I now have a solution because I take the x value 1 and the y value 5, and I write them in an ordered pair. Right? The very last thing is to check our solution. The way we check is to make sure that the solution works for both equations. So we're going to take the first equation and we're going to plug in the numbers. So we'll take that equation y equals, but we're going to substitute 5 in for y, and then 3 times x, and we're going to substitute 1 in for x, plus 2. We do the operation, so 5 equals 3 plus 2, 5 equals 5. That ordered pair worked for the first equation. Now we want to check it for the second one. So in place of x, I put 1 plus 2 times y, and y is 5, equals 11. I do the operations. 2 times 5 is 10, and then 1 plus 10 is 11. 11 does equal 11, so the ordered pair is a solution to both of the equations. Therefore, it is a solution to the system.